Our A2 question. This question is about kinematics. Now, these formulas over here relate to your kinematics. It's when you have constant acceleration. There's one other formula that's useful, that V is equal to U plus AT. Important that you know what all the terms mean, the U, the V, the S, the A, and the T. And let's have a look. We can apply those formulas here. So Lucy stands on the edge of a vertical cliff and throws a stone vertically upwards. The stone leaves her hand with a speed of 15 meters per second. At the instant, her hand is 80 meters above the surface of the sea. Air resistance is negligible, and acceleration of free fall is 10 meters per second minus 2. The first part, calculate the maximum height reached by the stone as measured by the point from the point where it is thrown. So as measured from the point where it is thrown. Alright, so we need to see what we have got, and what we need to find. So I'm going to write down here, instead of writing A, I'm going to write G, because that's our acceleration, and T. So we are actually looking for the S. We are looking for the height, because this ball is going to go up a certain amount and then it's going to come down. We're looking for this height here, that height, which we're going to view as our S. So this is what I'm wanting to find. What is my U? This is my U over here, is 15 meters per second. Our V, so we're looking at the top. This will be your U is your initial, your V is your final. So at that point over there, it stops, so your V there is 0. So this is 0 meters per second. Now, your G is given, your acceleration is 10 meters per second, but we need to be careful with direction. Because your G is acting in this direction, 10 meters per second to minus 2, I'm going to make that a negative 10 because it's acting down. I'm going to take my upwards as being positive, downwards as being negative. So that's going to be 10 meters per second to the minus 2. Time, we haven't been given anything with time so far. We're going to work that out later. So, which formula am I going to use? Now, I don't have time. I want to find my S. So I really am going to use this formula over here, because there I have got my V, I've got my U, I've got my A, and I want to find my S. So I use that formula. V squared is equal to U squared plus 2. I'm going to write GS there. That's 0 is equal to 15 squared plus 2 times minus 10 S, and we can change that S to H. So the 15 is going to squared is going to go to the side. It's going to become minus 15 squared. So it's minus 225. This is 10 times minus 2 times minus 10, which is minus 20, divided by minus 20 is equal to H. So when I divide 225 divided by 20, I get 11 meters. Your H is equal to 11 meters there. Then it says, determine the time for the stone to reach the surface of the sea after leaving Lucy's hand. So now we've got a bit of a change situation here. So now we're looking at the whole motion. We're looking all the way from there. We've still got our initial velocity there is 15 meters per second in that direction, but we're going all the way up and coming all the way down. So what is going to be my final displacement, S? Let's write these things down again. My S, U, V, G, and T. Well, we know T is what we want to find. We know that G is minus 10 meters 1 second squared. We don't know what V is. We're not sure what V is, but we do know U. It's 15. Now, notice here my sign. So it's minus and plus. And my S, important, is actually going to be minus 80 meters. Because if I've chosen this direction to be positive, my final displacement, remember the final displacement is always from the end to the beginning. So that is my final displacement, that amount over there, and it's downward, so it's minus 80. All right, so which formula am I going to use? Can take these out. We're going to decide. We want to find t, but we don't have your initial velocity. So probably we don't have, the final velocity. So this one won't work because it's got no t. This one won't work because we have not got our v there. So this one looks like a good candidate. So we put that in. We're going to get minus 80 is equal to ut. So that's going to be 15 times my time plus a half times by minus 10 times by t squared. So I'm going to get minus 80 is equal to 15t minus 5t squared. I can solve that. There's different ways of solving this, but probably the best way to solve this is to use your quadratic formula, that x is equal to minus b plus or minus b squared minus 4ac divided by 2a. There's not much space here. Let me work over here. I'm going to rewrite this formula over here. I'm going to have, that's going to be 5t squared, bring that minus 15t minus, I don't know why I've changed this to 18, that should be 80, sorry about that, minus 80 is equal to 0. I can divide that all by 5, so I get t squared minus 3t minus, that's going to be 10 16 minus 16 is equal to 0, and then I put this in. So my a is equal to 1, that's a number over there in front of your t. Your b is equal to minus 3, and your c is equal to minus 16. So I'm going to get t is equal to minus b, so it's minus 3 plus minus b squared, that's minus 3 squared, minus 4 times a is 1, times c, minus 16. And we're going to divide all by 2 times a, which is going to be 2. So we're going to use our calculators here. We're going to get, this is going to be 3 plus minus, it's all going to be over 2, just work out what that is. That's going to be 9, and that's going to be minus, times the minus is positive, and that's going to be 64, so it's going to be 9 plus 64, so it's going to be the square root of 73, I think. Is that right? 4 64s, that's going to be, so it's going to be the square root of 73. So I find the square root of 73, and I get 8.54, so forth. Now, when I've got two answers here, but when I subtract 3 minus 8.5, I get a negative value. That's not possible. We don't get negative times, so that doesn't give me a solution. So I just use the plus. So I'm going to get 3 plus, 3 plus my answer divided by 2, and I get 5.77 seconds. And let's see to the number of decimal places, a number of significant figures. We were given there's 2 there, 2 there, so it's going to be 5.8 seconds will be the time. Okay, so you could have also, there's different ways of doing this. You could have also done this where you worked out the time for it to get to that point, and then so you say call that T1, and then you worked out the time that it took to drop all the way down, and your final time, your total time, would equal T1 plus T2. You could have done that. Important point is to know your formulas, write down all your information, go through and make sure that you know all your information, put that all down, choose the correct formula, and then solve.